All right, so we are on the final question, question 10 of this book here, Generalized Linear Models with Examples in R. Let's see here. Okay. So we have another data set from the GLMsData package, and we want to do a few things with it. So we'll just go through these piecemeal. Okay, so first we need to load the package. Well, we need to install and load the GLMsData package. And then we're going to call the appropriate data set, mandible, and then I'm going to assign it the label D just to cut down on typing. And then we'll kind of see what the structure of the data is here. Okay, so it looks like we have two variables. One is a real, right? It can have decimals, and the other one is integer. And so we have age and length. Okay. We could probably even learn a little bit more about what this is if we went with mandible. Okay, so it gives data of different fetuses measured by ultrasound. Okay, age is in weeks and length is in millimeters. There we go. Okay. So the first thing we're supposed to do is to plot the data and then determine any important features. So let's go ahead and plot this. And this is what we have. So we have length on the y-axis, age on the x-axis. And so I guess to me a few things jump out. One is that the middle of the data seems to be pretty linear, right? As I go up in age, the increase in length changes pretty linearly. However, it seems that as we go up in age, the variance around that center point at any given age gets wider and wider. So the variance in length is increasing. And then the last thing, although it's not really made explicit here in the graph, but we should just be able to reason this, is that both length and age are going to be lower bounded, right? We can't have negative length and we can't have negative age. So, all right. So the next question is a linear relationship appropriate? And explain. So it depends a little bit on what we mean by linear. If we just mean does the average value or the expected value of the y variable length increase, linearly or straight like a straight line with age? Yeah, that's true. But sometimes when somebody says a linear relationship in this world, sometimes what they're meaning is do the assumptions of normal linear regression apply? And one of those assumptions is constant variance, and that one is violated. So while the relationship is linear, it probably fails the assumption of constant variance across the explanatory variable. Okay, and then finally, number 3 is a model assuming constant variation appropriate? Well, no. Just like we can see in the graph, it's not appropriate. Now, none of this means that there are not ways of handling the variance or the inconsistent variance. There are ways of doing that. I would check out Ben Lambert's econometrics for some. I'm not sure if those methods are described in this book or not, and so I won't go into it. But one of the things that we might be able to do is to just simply transform the variables. And so the question doesn't ask for this, but we'll do that. So we'll just log everything. So we have log length, log age, and we'll plot this instead. And so we still have a pretty linear relationship, and a lot of the variance problem has been taken care of. So anyway, we'll call that good. And I guess we're on to chapter 2 next.